theoretical part of it is there from understanding, as well as the statistics behind this particular part. Okay, so let me start sharing my screen, and then we can start with our session. So any doubts in understanding so far the dashboard that we were building and the logic with which we were building, or calculations, formulas, anything which is coming in your mind, please feel free to ask me directly. We can take that up in today's session as well. Okay, so anything respect to any of the element or functionality or anything, feel free to ask me. We can take that question on the fly as well, or at the end as well. Okay, so we were at this situation or at the stage where we have created our almost 90% of the requirement, which is to see the performance of department. So here only one thing which is missing is that we don't have the title. Okay, so the chart title is not there. So what is exactly the chart title that we wanted to see? This is department wise performance, right? So we can change all these things. We can say department performance. Okay, great. We have department performance, we have individual performances. We know from the dashboard perspective, like what exactly do you want to see, the overall satisfaction score, all other details, right? We know we want to create all these elements. There are a few things that we wanted to add in, like you see here, the individual charts. This chart has an outline, even this chart has an outline. You can have one consolidated chart, just like an insert. You can say any particular shape, and then you can make this shape transparent, and then only add the outline of it, and then you can work this as a one individual entity. Okay, considering these two things are related, right? These are satisfaction score for individual basis as well as for the overall element. Okay, so this is what we were at a stage, and we will see how to add this gauge chart to our analysis. Okay, so let me quickly add this bit here. Okay, so let me take it down over here. We have another bit here. We understand that, okay, these two things, how these two things are different, right? We have checked that. So let me just add both the elements. Okay, just a moment. Okay, we'll add these two here so that we will still be able to see the diagram. Let me make the size a little bit small. Okay, so now you see we were at the stage where we want the satisfaction score from here. Okay, so we got a particular score, we got a particular gauge, we know how we have built it, right? We have added one donut chart which will tell you the actual total satisfaction ratios, which will come from point 1 2 3 4 till the 5, and then at the middle it will tell you for that particular week what is the overall satisfaction rate, which you see over here. We have calculated for overall satisfaction, which is 3.43 for this week, whatever week we have selected. We can change the week, and then the score will be changed. So here what are we saying? That okay, these are individual satisfaction issues. You can add the you can say individual values as well, or else you can hover on that and then you can see. But here we are not interested in looking at the exact value of all these individuals who are getting a satisfaction score. We just want to see the ones who are performing as per the benchmark, which is to have it like more than 3.5. So our focus is on that, not on number. So whenever we build any visualizations or visuals or dashboard, we have to also understand not all information related to a particular chart needs to be visible or needs to be popped up directly on top of it, right? Yeah, when you see this department, this particular flow of what exactly is the SLA and what is they call abandon rate over here, here it is very important for us to understand at what percentage it is crossing the SLA, right? If the SLA is 20%, we know that the toaster department is close to it, but at what metric? Like, is it that it is like 19.9 and that's why it is not coming, but it is almost touching that particular SLA bar, right? And even over here in air conditioner, we know that again what percentage it is higher. So if the SLA is 20%, if your one department is doing 21% for a week or so, it is still not impacting the business. But if the SLA is 20% and you are getting a 35% abandon rate, then it's a high, you can say a big signal to highlight it to the business that, okay, this is where there is a lot of problem going on and we have to look out for a solution over there. So in that sense, looking at the numbers for each of the department along with the color and SLA is important here, but not that important over here where we are just focusing on, okay, who are the individuals who are crossing it. And in general, you will see that total, if you have 8 individuals, out of which only 3 are following the particular, you can say, benchmark for satisfaction ratio, and we have to promote more so that at every week I should have these smileys for more than 80% of my total individuals. So there are a little bit training required for the individual members as well for the company to get a better satisfaction ratio. Okay, so along with that, we'll also see that what will be our, let me just add it. So what will be our overall satisfaction ratio? So for that, what we will do, we'll go to insert, and after going to insert, we'll take a text box. Okay, let me take a text box. Let me create it over here. Okay, and let me add the name over here, satisfaction score, and this I will put it over here, and then I will add another text box. Let me just make this Control C, Control V. Let me add the actual score that I want to put in over here. Okay, I will change this. And then we had to link that particular box, right? You know that how we are doing the linking of all the elements at the top, right? The week 1, week 2, the values and all. How are we linking? We are just clicking at the corners, letting this particular blinking go away. Okay, if I click a text box, you see the blinking in between is happening. That means whenever whatever I write, it will show me over there. But now what am I doing? I have to link it to a cell. So that's why I will click at the corners or in the middle line, not on the top, and I'll see that, okay, if the blinking stops, yes. Then after that, I'll click on equal to, I'll go to the calculation sheet, I'll select this sheet, and then done. Okay, so you see here, so this is how we get the data for a particular cell, and this is a week wise basis. The impact is then, now we can do a formatting of this. Let me just select this, so I can select this, go to shape format. Okay, and in the shape format, I'll say I want no fill, I want no line, and the color over there, I want the text should be somewhere like dark blue with a bold effect. Okay, so let me just select this bed, go over here, select bold, and a little bit higher number. Okay, like this. And in the satisfaction score also, I'll do the same formatting change where I don't want the shape, color, anything. I'll say no fill. See, if you have white as in the fill, white color, it will look like a no fill for you, but whenever you overlap it to any particular object, or when you have a different background, like sometimes you have a darker theme and all, these kind of elements would be not good to see, and then you have to make those changes. So that's why on a normal basis also, you have to keep these things as it is, right? You have to keep all these formatting as it is. You have to increase a little bit of the size on this score as well. Okay, and then we have to also add, suppose, just like colon over there. Okay, so now this is added up. Now you see here, Now let me see if any particular week is, if we are changing, the values are changing or not. Okay. Okay, so the values are changing, but it's just that the value that we want over here from this part, it is not changing. Why is it not changing? Because whatever we have created over here, this value, okay, you see here, this is a static field. So that we have not changed anything. So over there, we have to make the changes so that the arc will always represent that whatever the value that we are adding in, that should be your actual value. Okay, so how we will do that? Let me add this bit. This is what we have added over here from 66. We will select that this should be equal to our value which we have over here, which is the satisfaction overall ratio. This, and multiply it by 20 so that we have the actual information which is calculated as per the 180 degree surface, right? So we will just multiply it by 20 because we know each arc will be of that level. Okay, and then after that we will add this bit. Let me just go over here. We want the total to be 100, so we will put this 2 over here, and this is the actual value that we want. So why are we doing this? Let me just add equal to again. Equal to 200 minus this value minus this value. Okay, so the idea behind this is that you have to understand that how we have built this part. Okay, so I will just explain it to you because sometimes this is a little bit confusing to understand what are the numbers. See the chart that we have built. So we have built a donut chart, full donut chart. In that donut chart, what we have done, we have added the start line over here. Okay, so this is our 0 line, and we have taken this particular segment as our final segment. So that means I have taken only the first half of the data, the visual to be shown. And in the first half itself, I have formatted 3 segments. Okay, what are those 3 segments? The first segment is, suppose, the red bar where we say, okay, if it is 50%, that is the minimum bar. This is our 50% bar. Then we have this bar, which is our, suppose, the amber color, okay, with the percentage, and then this color. So here the percentage basis from a circle perspective, which has a 360 degree as an angle, which we are saying that okay, this is only 180 degree where we'll be focusing on, and this circle total score that we are taking is 100, and the rest part over here which we are, you can say, hiding it, is again 100. Okay, so if I say the total value of this donut chart is 200, out of which this 100 part is hidden. Okay, let me just see the people who are still joining in. Okay, so this 100 is hidden, and the rest 100 part is split into 3 areas, which is your bad performance and average performance and good performance. And this is where we have created these arcs. Okay, and this arc has to be a spread of 100, and the total will be 200. Okay, and that's why if you see the calculation, what are we saying here? That the total arc 50, 20, 30 is the percentage. That means we have taken that 50% is bad, then similarly for 20% and 30% for average and good performance. And this performance, which is a number, has to be converted as per the value of satisfaction score, right? We Everything we are building over here is on satisfaction score. That score, we should see that what is the range of that score that it can go to. So for that score, if you go over here and then see that okay, what is the satisfaction rating, the minimum and the maximum, it is 1 and 5, or else 0 in case they have not shared anything. So we know that this arc, which is separated for 100 units, this will be shown from 1 rating to 5 rating. Okay, 1 to 5 rating. So if it is 1, this 100 should take a value. Similarly, for 5, it should take the last value, which is 100. So in that case, every rating, what will be the every rating size? If you divide it by 5, it is 20. 20 is the score for each of the units. So if I say 1 rating, in our bar, it should show as 20. If I say 5, it should show me 100. So it should take the last value. Okay, that's why we have divided this everything for 20 as for each of the satisfaction rating. It will take a value as 20. So now what are we doing here? You see, we are multiplying whatever the value that we are getting over here, whatever the number is. Like, we know that if it is 3, we have to just multiply it by 20, it will be 60. If it is 1, multiply by 20, it will be 20. So now we are getting a satisfaction score 3.52, and we want 3.52 to be plotted on our donut chart. So what we will do, we'll just simply multiply it by 20, and that's what we are doing over here. When we multiply it by 20, we get 70.476 as the value. And this is what we have to populate. No other confusion. We will take 70 value, populate it. But then when you populate this value, it will be a point. Okay, it will not be a arc. When I say that point as it is, this will be a small point over here. Let me change a different color. So if I say 20 or 3.6, this will be a small point over here, not an arc. And we have to build an arc. So for that, what we are saying, let's make this arc a size of 2, so that it is visible. And that's why we are adding over here the value of 2, and then the rest value, right? The rest value, which is overall circle value 200, we are taking that value 200 minus the start point of that particular score minus the arc value. That is what we're left with, 127. If you sum this up, this will be 200. You see at the sum on the corner. Similarly, if you sum this, the rest part, it is again 200. And that is how we are building this particular arc. Now when we go to sheet here, you see 3.52 is taking a particular value. Now if I change this 3.43, it is again on the similar lines. So it is, the arc is also been changing accordingly. Okay, so you see 3.25, it is coming in the yellow portion, which is 50 plus 20%, and your respective overall number over here, and this value is changing. Okay, pretty much clear on this understanding how this is working. Okay, so we got the satisfaction score, we got how to make the arc, we have also seen how to take this value. Okay, now the last bit which is required is the overall performance that we want to put in. So for that, what we will do, same logic what we've been doing till now. We will select a particular box. So for that, I'll go to insert, I'll go to shapes, I'll add a shape from this alignment. Okay, I'll go over here, I'll say no fill, but I want a shape outline of this color, which is a little bit lighter shade. Okay, now I will add in all the values that we want to show as a business metric over here. So for that, what we will do, let me just quickly go over here. Okay, now we can insert another bar over here at the top. That will be the header of this part. So we'll go over here on the shape. We will add this bar. Here we will write it down that this is SLA limits. Okay, let me just increase the size. Then I go to home, make it bold, make it little bigger, center align, done. Now there are few information which we have calculated and pending right now. What are those? If we go to calculation, you see the call less than 180 seconds, percentage of calls less than 180 seconds. All this information is still there. So if you want to populate that bit, what we will do, we'll add the text box again. So let's just go over here, go to insert, add a text box. Or before that, let me just copy this bit. Okay. Now we'll go over here, add a text box. We'll draw it and we'll paste that value. Okay, it is. I think the pasting didn't work properly. Let me do that again. Okay, now if I go to calculation bar, copy this bit, only the value we have to copy. So we'll just copy like this. Go to sheet, go over here, paste it. Okay. Now we have taken the other metric which we wanted to show. Okay. Now we just want the information that we want. Okay. Whatever the information that we are having, we just have to keep it the number. So we will change the color. We'll make it a little bit formatting. We'll do the changes. So let me just select it. Let me make bigger. And then over here, I will go to shape format. Okay, I will select a shape fill, which is no fill. Shape outline. Okay, this is good enough. I'll go to home, increase the size, make it bold, or not that much of a bold. So let me remove the boldness. And then I will change the color of the text to blue color or a little bit darker blue. Okay. So call answered in less than 180 seconds. Okay. How many numbers are there? So calls, let me just put it up. Answered in less than 180 seconds. So how many such calls are there which we have answered in less than 180 seconds? That's our first bit. Okay. Let me make it smaller. And then similarly, let me add another text box here. And with this, we will start putting up, okay, the other information, which is calls with satisfaction ratio. Let me just put this quickly. Calls with satisfaction score less than 3. Okay, this is what we want to do. So let me just add quickly, Control C, Control V. I will just remove this size, keep it next to this. I'll copy paste again and keep the other bar over here. Okay, so now what we will do, let me take this number out, select this bit, again go to formula bar at the top and go over here, the calls answered in less than 180 seconds. Right, call answered in was less than this is this particular bit. We'll click on enter. We got the value, right? We'll just change the value, change the color, increase this bit. Okay, so now as this number, whatever the number we are getting, I'm just putting it over here. And the calls with satisfaction score less than 3, whatever the number it is, will go again. So here one more thing, you can just select this any box, click on format painter. You can click on another box, the formatting will be copied. Okay, just that only the formatting will be copied and not the actual number or the formulas which are associated with it. Okay, so here in our case, what we will do, we'll select this bit, put equal to, go to the calculation sheet, calls with satisfaction show less than equal to 3. We'll select this, click on enter. Now you see the problem here is that the calls are really high. If you see total calls are 482 and here the you are getting 183, that means the the calls are really high from the numbers perspective, and it's a bad sign. So what we will do, we'll select the same bit, but this time the font color should be red because this is a negative performance. Okay, so we'll select this bit. The only thing is that, okay, let me select that the outline, we'll just remove it. We just quickly add no outline. I will select this bar, go over here, no outline. I'll select this bit as well. I'll go over here, same thing. We are removing the outlines because it doesn't look good over here. Okay, so now the numbers are tagged to this. Let me just see if I can add over here and this bit to this. Let me decrease the size a bit. Okay. Okay. So now you see the numbers that we have. This is a good metric. So this color should be suppose in the green color, and this is the bad metric. So it is 183. Should be in the red color. So what are we doing? We are checking for now. Our dashboard is ready. So when you have your dashboard ready, okay, and there is a little bit scrolling in your dashboard, what you do, you remove the formulas. Okay, so let's go to view. We'll remove the formula bar, we'll remove the headings. Okay, and we will also take this particular arrow button or wherever you see the control bar to upside. Now this is your dashboard. Okay, now you see the look and feel of this dashboard makes it look like a BI tool which will give you all the information related to your business without having any you can say external intelligence given to this. Okay, now if we make any changes, let's see, if you want to see the call resolution wise the agent who's really good, you see the information is Joe, Jim and Greg, they are really having a good call resolution. But when you see the satisfaction ratio or the rating that they're getting, Joe and Jim, they are resolving the call from their end, but the customers they are handling is not good. So these kind of highlights is, as a business analyst or a data analyst, you have to highlight that they are the worst performer in the satisfaction ratio. You see Joe and Jim, even though the call resolution is really high and even the call overall calls is also like for Joe is really high, but the satisfaction ratio is not good and we have to do something over there. Greg is a good decent person. Now if we see, okay, if this is the case for week 1, let's see, okay, for week 2 or so on, let me just click on to week 4 in general. Now you see for week 4, Dane and Dan is good. Dan is really good over there, but Greg is again coming up. So you can say for week on week basis, Greg is really good in handling the customers and getting a good satisfaction rating, because satisfaction rating for any call center or any service industry where they are handling customer is very important. Okay, so in that sense we will form all these elements accordingly. We'll see highlight all this thing. You can also highlight the number over here, right? So right now we have not kept any number on this. You can actually go there and then highlight the numbers as well. The only challenge with that is, like, suppose if I add the data label, the label will be the value that I am getting and not the actual score. So for this also you have to change the particular element and change the value to this text box, and then you can show that. Okay, so we'll change other elements. Okay, the washing machine, toaster, this everything is working fine. Okay, there is all the functionalities are working fine. Okay, so this is what is the end objective for our dashboard that we have created for call center performance and all the formulas that we've been created. Okay, any doubts on any of the bit, guys, you can unmute yourself and ask me, or else you can put it in the chat as well. I will take it for the next 2-3 minutes and then we'll jump on to a new concept. Anything from anyone? Let me see the chat. Okay, I'll wait for another 10-15 seconds in case if you're typing your query. Okay, so till the time we are waiting for others for the query part, you see your dashboard should always have different elements, right? If you remember at the start, right, we have the header at the top. There is no company logo, but here you can add the company logo also on the left hand side, and then the username on the right hand side. You can add the department who has created it, right? If you are in the BI department, you can say created by BI team or things like that. You can add disclaimers at the bottom as well. Okay, sometimes just like when you go, these are all you can say the additional qualitative field, right? You can add a disclaimer button saying that okay, all the data is confidential, right? Data is confidential, strictly not to be produced outside the organization. And you can put this kind of a thing. Go over here at the top, change it to italics, make it a little bit grayish, and put a sign like this with a star marks at the start. That also you can put in. Right? You can add a disclaimer kind of a word, and then try adding it, and just add a disclaimer at the bottom like this. Make it more visually appealing and things like that. Okay, let me see. Okay, no questions. So that means everyone understood this part. So with that, we'll get into our next bit, which is equally important for a business. Okay, that is hypothesis testing. So when you know what kind of formulas you can use and to solve for business challenges and problems, along with that, you also know how to present it to some extent. Now we have to understand how do we arrive at a conclusion, or how do we start in understanding what information is required, or whether whatever we are building solve for the actual business problems. What are the metrics which are required, and how to justify or move ahead with our calculation consideration. Okay, so with that we will discuss a very important topic of statistics, which is hypothesis testing. I have taken a presentation directly from the same book reference that we use for statistics for business economics. Okay, so with that, I will also explain you how exactly we understand this part of hypothesis testing. Okay, so I'll explain you what exactly are the different elements and things related to it. Let's just understand few terminologies first. So we'll be understanding what are the two type of hypothesis. One is null hypothesis, the other one is the alternate hypothesis when you try and build it. Then we'll also see the applications using population mean and normal distribution. We'll also see how to formulate a decision rule, right, which is based on hypothesis testing. We'll also see, generally you might have seen in your statistics books, or you might have gone through this, that we say with what confidence interval are you saying this, or when you are saying something, when you're proving something, what is the accuracy of your model or your analysis. So we'll see how to get to that critical value and figure it out how to test for null hypothesis. Then we'll also see whenever we build on hypothesis, there is a chances of making errors. Okay, whenever we work on this, and the error can be of two types. So there is a type 1 error and a type 2 error. It is not exactly like there are two types and type 3 will be coming in. The name itself, type 1 and type 2, is very, you can say, important and running in the industry as an example with the same name. Okay, so we'll understand the errors and their relevance. And then at the last, we'll see the power of test measure. Okay, so I'll explain you few elements with the help of a diagram. Let me create this. Delete it. Okay. So see where and at what level we generally discuss about hypothesis testing. Okay, let me select this bar. Size 2. This has to have a little bit bolder. Okay. So, which all industries it will be coming in? It will be in all industries and all divisions. Okay, including the HR, marketing, finance, and all the metrics wherever we see data related to it. Okay, whenever we have the data. What exactly it means? It talks about what is your belief. This is where it will revolve around. We'll say my hypothesis is tomorrow it's gonna rain. That means your belief. The another word for hypothesis is belief. What we say in the business, that my business I think depends upon the availability of goods. Or if I am into agriculture business, my crop sales depends upon the amount of rain happening in this particular city, right? So that means I have a belief, and that belief I'm writing as a statement. So when you write a statement, you will say that okay, this statement can either be proven as true or can be proven as false with some testing, and that testing is called hypothesis testing. And when you build the hypothesis, you have to write down both the sides of your belief. Just like as simple as I'm saying that tomorrow it is going to rain. So in that case, the element that I'm focusing on, the bit that I'm saying, will fall under null hypothesis. Okay, there are two types, right? Null will always be what is your actual belief. I'm saying tomorrow it will rain. Okay, what is the opposite of it? Tomorrow it will not rain. So the alternate hypothesis, which we say for null, null is our belief. The another one is alternate. Okay, the alternate hypothesis will be it will not rain. Okay, it will not rain tomorrow. So in this case, now we have figured out our hypothesis is I'm saying tomorrow it will rain. That is on my null hypothesis. The alternate part is it will not rain. And I will test my hypothesis on my null hypothesis, the statement which I am putting over here. This is our important thing. If I'm able to prove with data, I will either accept null hypothesis, right? Where I will say I fail to reject null hypothesis, or else I'll reject null hypothesis. We will not say any statement based on alternate hypothesis, that alternate hypothesis is accepted or it is rejected. No, it is just to form the alternate hypothesis. Every testing has to be done on null, and we'll say this is how we will say at the results at the end that we either reject null hypothesis or fail to reject. Okay, this is how we'll be doing it. So now, to take the same example, if we are saying tomorrow it will rain or not rain, this is our hypothesis. We have to test it. So first thing we have to figure out is what data is required. Okay, you will figure out that okay, I need the weather report for today and for what timeline, right? I need suppose last 5 years of data. I need for data for 5 years for the rain, whenever it has the rain is there, right? So we need the timeline, we need the weather data, and we need whenever the rain has happened, we need humidity, right? We need the wind direction and the speed, and all these things we find out. So that means we'll figure out what all data is required to check this hypothesis and to see that okay, we say okay, it is more of like a predictive nature. Okay, and we'll say that okay, based on all this data we are trying to predict it and this is how it will happen. Or else you can also write the same statement in a way that okay, if today the temperature will go up from 25 degrees and whenever from a particular temperature it will go up by 10 degrees and it reaches 35 degrees, it will rain tomorrow, right? So all these conditions can be added in your null hypothesis. You can say with any particular logic, okay? And that is what exactly is a hypothesis building. Testing will get into it with detail, but right now we have to understand what is hypothesis, what are the components of hypothesis, and after forming hypothesis, what we do, we try and work on the data, and then we try and work on testing, and then we'll save this information. So always whenever you build hypothesis, you cannot get the exact data, right? If you are saying that, okay, I am saying my hypothesis is in Mumbai, the average age of any particular person, or in general the population average age is 33. So this is my hypothesis. I'm saying Mumbai average age of people is 33. Now what I'll do, I'll go and target all these individuals, right? I'll go and talk to all the people residing in Mumbai in different areas. I'll go and ask their name, their gender, and their age, and I'll write it down. It is impossible for me to reach out to every individual staying in Mumbai, right? I have to depend on either some secondary data, or I have to do my own research by meeting everyone and getting their actual age. So there will always be a case where I will talk about sample. Okay. So at the end, let me erase a little bit of the data. Okay, so there will always be a case where we will talk about some samples. This sample will be derived from population. Okay, so that means the overall data is our population, which I'm saying in my case, I'm saying in Mumbai. So I will have some Mumbai's population, which will be somewhere around, like, suppose, let's say 25 lakhs. And in that, I'm saying 25 lakhs people, the average age is 33. That is my hypothesis. And what I'm doing, suppose if I have a timeline of 1 week to gather data. In that 1 week time, I will reach out to 5,000 individuals. Okay. And this 5,000 people will be my samples on which I will test my data, and I'll say that, okay, out of this 5,000, I have the age of all these individuals starting from like 2 years to almost 60 years or 65 years and so on, and I'll take the average of it, and then I'll say, yeah, average of 5,000 people is coming around 32. So I can say that the hypothesis of having the age or average age in Mumbai of 33 can be accepted with the confidence interval of 95%, because 32% is our actual number, and we'll see what is the analysis of variance and so on. So basis on what is our sample, what is our population, what is the data, we will test it, and then we'll arrive at a conclusion whether to accept or reject the particular hypothesis. Okay, so this is what we are going to learn. So one more aspect, when we will do all these analysis of accepting or creating the hypothesis, creating the alternate hypothesis, and testing another element, last bit is when you create the hypothesis and then we'll see the result. When we talk about what are the type of errors you will do, is let's understand that from a confusion matrix, in case if you have already having an idea. This four quadrant matrix is called confusion matrix. Okay, suppose I am categorizing that a particular element. Let's take this not from hypothesis perspective, understand this from a confusion matrix perspective. I am trying to identify whether a particular person is having cancer or not with some test. And then that test is not medical test. I'm saying from the appearance perspective, I will say, okay, this guy, if his hair quality is really good, he is not having cancer. If it is bad, there's a possibility of having cancer. So what I'll do, I'll have the actual data, right? Actual people who are having cancer, actual results where people are not having cancer, no cancer. And from our analysis, from our analysis perspective, from our prediction perspective, we are saying people who are having cancer, and from our analysis we are saying these people will not have cancer from their appearance or their hair quality and all. So when we have predicted for cancer, no cancer, we have actual when people are having cancer and not cancer, either we will have a right prediction. Okay, I will change the color. We'll have a right prediction. The people who are having cancer, we have predicted that properly. We will also have a right prediction where we say the people who are not having cancer, we also predicted them as not having cancer. So these two things are called the right predictions, the accuracy of it. The precision and recall are the kind of errors that we are having. So here there's a type 1 error. Okay, this is error. So why this is called error? Because the people were not having cancer, but our prediction said, oh, they are having cancer. That means it's a false positive. Sometimes type 1 error is also called as false positive. Having cancer. Similarly, we have another error. Here the people are having cancer, but we are saying they are not having cancer. This is type 2 error where we say false negative. We are saying they are not having cancer, but they are having cancer. So for every business use case, for every, you can say, kind of business, the error which is more, you can say, dangerous differs accordingly. Okay, in your interview, if you are getting into statistics and business, this will always be a question on hypothesis, definitely, and they'll ask you which error is dangerous for an organization. And for your answer, it is not just one kind of an error for all the organizations. It depends on what kind of organization we are working, what industry we are working in. If our industry is into drug manufacturing or aircraft, we cannot have a slight possibility of error, right? So where we will say that okay, chances of having error is very dangerous for us. Okay, similarly in law and justice, you might have seen in movies, or if you are reading law, or if you have some references in law, what we say that a culprit can be ordered as free. Okay, we can make a particular culprit as free and should not punish him, but we should not, or we should never punish a guy who's innocent. Okay, so an innocent should never be punished, even if a guy who is guilty is left as not punished, and they're not being behind the bars, or they're not being asked to go back. So in that case, what is important for us, what kind of error is important for us, is that the type 2 error. The person who is a culprit, even if he is a culprit, we can just put him as a free man, but the person who is not a culprit should never be sentenced. Similarly, we have pharma. A bad drug should never be passed and should be given for human trials, right? Even if a good drug, we are saying it is a bad, and we are rejecting that drug, it's just a, you can say, a monetary loss for any organization, but there is no life loss, which is very crucial for drug manufacturer, right? Similarly, the other option in sales predictions and other thing where we say no, when we wrongly identify a particular business and predictions, we are saying that the kind of products that we are delivering, just like toys and all, a bad toy can still be produced with an error, that color is not mismatched, the color is not added up. But if you do that rejections, it will be a lot of monetary loss for the organization, which we can still proceed further. Okay, so it depends on different use cases that we have. Now we will see what are the different hypotheses that we create with an example. You see, the hypothesis is a claim, okay, just like assumption that we said about a population parameter. So we have a population mean, which we say with mu. So the mean monthly cell phone bill of a particular city is $42. Okay, Then we have a proportion. So example, the proportion of adults in the city with cell phone is 68%. That means we have to understand the data that you are having, what that data, how much percentage of the population that data is being captured. Just like in our example, when we are reaching out to 5,000 individuals, we have 25 lakhs people. We will say 5 lakhs by the 5,000 by 25 lakhs is our population proportion, and basis that it should always be more than 40%, right? You cannot ask just five people and take their age and then say, yeah, the population of this city is this. No, five people is not a correct representation of that particular population, right? So now we have different states of assumption. If it is a number, so the average number of TV sets in US home is equal to 3. So that means in, you see H naught, this the sign H naught is your null hypothesis, and HA is your alternate hypothesis. So the example over here for null hypothesis H naught, where we say the assumption, the number is to be tested. So how we should write in the null hypothesis? It should always be a population parameter, not about a sample statistics. Okay, so we should not talk about X bar. In case if you are um, like, yeah, I believe that you already have covered the statistics part and all. So when we say sample mean, it's always denoted as X bar. When we talk about population mean, we generally denote it as mu, and whatever information that we talk about should always be about population. Sample parameter is only for testing, but when you create hypothesis, it should always be on population. Okay, and there's one more important part. I think in the quant and statistics, people don't say this. You have to just take it as your observation. You should always have equal to sign in your null hypothesis. Okay, when I say equal to sign, what it means, I'll explain it to you in this the corner area, the bottom corner area. Let me just increase this a bit. Okay. So now what I'm saying is, if we are forming hypothesis, in that hypothesis, I am writing null hypothesis, which is H naught, and then I am writing HA. All the H naughts, all the, your belief should always be either one class is equal to, and the alternate will be not equal to. Tomorrow it will rain or it will not rain. So equal to or not equal to. From numbers perspective, it is equal to or not equal to. This is one type. Other type is the average income of this particular city is more than $3,000, okay, per month. So if I am saying that, so what I am saying, average income is more than 3,000. So that means it is greater than equal to 3,000. So for this, what is the alternate hypothesis which will become? It will be less than. So the equal to will always be with H naught only. Either it will be equal to or not equal to sign, or is greater than equal to and less than, or else it will be less than equal to and greater than. These are the three types when we work with numbers. We have to make sure that in alternate hypothesis, equal to sign will always be over here at the top. Okay, so this is whenever we work with numbers. Let's move ahead and just close out on what exactly we do over here. You see, we begin with assumption that the null hypothesis is true. So we always begin with the assumption. So that's why I told you, when we form hypothesis, whatever is our belief is our null hypothesis, right? You see here again a law example, like a person is innocent unless proven guilty, right? So now we say that you see the sign, this is also what we have actually taken, equal to and then greater than equal to or less than equal to sign. Okay, it may or may not be rejected. So that's why we don't say anything on the alternate hypothesis. The only last bit that we'll cover for today is that what exactly is alternate hypothesis. It is exact opposite of null hypothesis. So the average TV sales is equal to 3 or does not equal to 3. You write H1 or else you write HA as the representation of this. So it should never have equal to sign in this. Okay. So it, when we say it is a supporting argument, we generally say that the researcher is trying to support, uh, right? So that means if I say something, okay, my belief is that, and I will put it the alternate hypothesis that okay, this is not exactly what my belief is. It is exact opposite of that. With one just example, you see here, our claim is, or our belief, or our null hypothesis is the population mean age is 50. So what is our hypothesis? H naught mu is equal to 50. We are not saying greater than or less than equal to. Understand the statement, English statement. Are we saying the average age of the city is more than 50? No, we are saying it is equal to 50. So with that statement, we have to understand the sign that is required in hypothesis testing. We are saying if the population mean is 50, so null hypothesis is mu equal to 50. Now select a random sample. We'll just randomly select the people. With that random selection of suppose 5 people, we are saying the sample mean that we are getting is 20. So our x bar is 20. So when we have x bar, which is our sample mean equal to 20, okay, mu is equal to 50. Do you think the population of 50, when we saying they are having the mean age as 50, is able to, you can say, we'll be able to satisfy the argument? We say if not likely, we have to reject the null hypothesis, because there's a good difference between the sample mean and the actual statement. So basis on that, this is a simple testing that we generally do when we say hypothesis testing. But we have ANOVA and other you can say chi-square test and t-test, z-test, and so many tests which we use to test all these hypotheses. This is a very important parameter for your certification, as well as for your in general interviews, and jobs, and you can say internships. Okay, so this is the concept that we will deep little bit deeper, and we'll cover this in our coming classes. Okay, any doubts, any understanding with any of the concept? I'll stop my presentation. Okay, I have something from Bhavuk. Bhavuk is, sir, while giving the presentation, will it not look somewhat weird that we are shifting the sheet and changing the values and then slowing the graphs? Okay, just a moment. Let me understand the question. Given the presentation, will it not look somewhat weird that we are shifting the sheet? We're shifting the sheets and changing the value and then slowing the graph. No, so we are not shifting the sheet, Bhavuk, here. This is one time done. I will save this now. I'll share the file with you. The user, either you are giving presentation by opening the same sheet, or else the user will get the sheet as it is. You have to protect all your sheets otherwise, right? Okay, you're saying while showing the graphs. Yeah, no, I know. I'm saying the value and whatever we are showing, you have to actually make it protected sheet for all your data and calculations. You will only show the information related to the dashboard, and in that dashboard also you can not show the formulas and other elements and directly show the charts, right? You have to hide and protect. You can do both, because if you just hide it, they can just click on it and unhide and then see the data. So with first you have to protect it and then you have to hide it. Yeah, no, the not the data. You have to just show only the dashboard sheet. Only the dashboard sheet where they can just play with the number of changing the weeks, right? And making the sorting option. That's it. They cannot do any other activity on the sheet. And that's the purpose of building the dashboard. Okay. We don't want people to play with the data and build their own charts and things like that. We have already created something for the business user. They should just use the dashboard as it is. Yes, yes, sure. Because I hope I answer your question and that's clear. Anything else? I was getting a question. That's why I think I misread the particular question. Is that do we, when we add so many visuals and you can say filtering and things, does it slow the dashboard in loading and all? Okay, so it definitely slows it down when you have so many macros running on the particular dashboard, when you have so many global variables, global filters, as well as respective table filters and views. So you have to make sure that whatever selections and filtering that you are adding, you should keep it minimal to a global level, and you should avoid it to the chart level information, because that will slow down your dashboard refresh. Okay, but that way we'll get into it when we see the actual little bit more complex information of the dashboarding that we'll be working on. Okay, but thank you so much for your time and patience to stick with the complete class. I will see you on